Hello, I'm Stephen Veneman, a quantum security pathfinding lead at Juniper Networks, and I'm excited to be here to share with you our quantum safe VPN solution with crypto agility. And in this session, we're going to walk you through a demo overview of our quantum security solution. And I'm excited to also be joined with one of our key partners in this area, which is evolutionQ, who is represented by Matt Jackson. So Matt?
Hey, everybody. I'm Matt Jackson. I lead sales and partnerships for evolutionQ. We're fortunate to be working with partners like Juniper and helping organizations understand the threat from quantum computers to their cybersecurity posture and how to begin upgrading. So excited to be here today.
Thanks, Matt. It's great to have you here. Quantum computers leverage a fundamentally different approach to computation as compared to classical or traditional computers, which actually may enable them to solve problems much faster and more efficiently than their classical computer predecessors. And as a result, they will be able to drive innovations that benefit humanity across pretty much every industry, whether healthcare, the environment, agriculture, astrophysics, communications, and so many more. However, there's also a risk, which is that their computing power may be able to enable them to decrypt existing internet security algorithms such as RSA and ECC, which would have severe implications on almost every sector. And while a cryptography relevant quantum computer is projected to be years, even decades away by some, the projected benefits of quantum computers are driving an increase in momentum of technology investment around the globe. And it's anticipated that $45 billion will be spent on the advancement of quantum technologies this year alone. And it's also projected that that number will grow over 2 times, so doubling in that amount to about 106 billion in the year 2040. And with the increasing pace of investment, a number of governments, regulatory bodies, and standards organizations are starting to take notice and are putting mechanisms in place, whether regulatory or standards-based, to ensure that the internet and the traffic that flows across it remains safe from potential quantum threats. So Matt, perhaps you can share a little bit more about the quantum threat timeline and some of the activities that are happening now to keep the internet secure.
Thanks, Steve. One of the biggest questions we always get is, when will this risk occur? And evolutionQ has been in the space for about 10 years now. We were co-founded by Michele Mosca, who's one of the leading academics and thinkers in this space about how to get prepared, why we need to start doing so now, and what that event horizon looks like. Every year, we've actually published a study that goes out to a number of experts in the field globally, both in academia and in industry, and surveys them to understand what is the likelihood and timeline for that kind of risk. In 2024's report, we had 1 in 3 of our experts actually believe that there was a fairly credible chance that by within the next 10 years, we would have a so-called cryptographically relevant quantum computer, one that's able to break those algorithms, as Steve mentioned. With all the latest developments that we've heard from Google and Microsoft and IBM, the pace of developments and changes is continuing. So I suspect in our next year's annual report that comes out typically in December, we'll see even further reason for those beliefs to be accelerated. And that uncertainty has often been one of the reasons why organizations pause on beginning to prepare for this transition to being quantum safe. We see a lot of government organizations, though, actually providing advice and guidance to government organizations or the companies within their countries that actually give pretty strong indications of timelines of saying to be prepared by 2030 or 2035, depending on the jurisdiction. More recently, though, we actually have another reason to be motivated to upgrade, and that's where NIST has actually come out with guidelines around the existing cryptographic methods, both elliptic curve and RSA, the most widely used ones today. And because of the threats of quantum computing, as well as other advancements, they're actually setting deadlines for the transition to these new, transition away from the existing algorithms that we have today, either by 2030 or 2035 to be disallowed and then deprecated accordingly. So with that guidance in place, NIST has actually started a number of years ago on a transition or a journey to establish new encryption algorithms. If you want to skip to the next slide, Steve. These new algorithms are often called PQC, or post-quantum cryptography. And the journey actually started about 2016 when NIST put out a challenge to develop new difficult math problems that would not be susceptible to the threat from quantum computers the way the existing ones are today. And so PQC is what all of the leading organizations are encouraging businesses to upgrade to. NIST released our first set of these algorithms back in August of 2024. And so that laid the groundwork where we actually know what we should be moving to for things like digital signatures or key establishment mechanisms. And so those are just starting to get rolled out and incorporated into other standards like TLS and IPsec and MACsec as well. And so with those kind of timelines and the ability to move forward, over to you, Steve, on what Juniper is doing about this threat.
So Juniper, along with various other industry vendors, as well as government regulatory and standards bodies, has been working together with these organizations to ensure that the internet remains quantum secure. And in addition to developing the PQC algorithms that you mentioned and highlighted in the prior slide, Juniper's also been working with standards bodies to develop standards to ensure that our products are able to remain quantum secure. And two of those key standards that we've implemented are the ETSI QKD 14 Open API and RFC 8784. With ETSI QKD 14, we're able to integrate third-party key management solutions or third-party key management systems into our existing infrastructure, whether it's our MX, PTX, QFX, SRX, of course, and some of our other platforms as well. The 8784, we're able to enable the SRX platform to generate quantum secure IPsec VPN keys, which can be transmitted across the network and used to provide secure, quantum resilient, or quantum safe links for traffic to flow across. And with that, I'll turn it back over to you to talk a little bit more about how evolutionQ is developing their multimodal key management solution.
Yeah, so a number of years ago, we were seeing these technologies be developed and the need for them to be deployed. And we started developing software solutions that would help not just deploy them, but help scale both QKD, PQC, as well as symmetric keys more recently. And so our Basejump platform actually sits in the middle between the traditional infrastructure layer of QKD, or what we'll talk about today in the multimodal side of things, and the more network-based applications that are deployed by folks like Juniper and their SRX platform. And so we introduce as Steve said, a key agent that integrates up with the hardware stack using an interface called ETSI 014. And it provides, we're able to leverage that to provide a quantum safe key. And because Basejump is able to scale between multiple technologies, we can retrieve that key via those QKD devices and doing so in a way that allows them to scale using trusted nodes and things like that. Or what we've more recently implemented is a new symmetric key solution called multimodal. So with that, we're able to actually support more types of use cases as well as a more resilient design into the network. So on the next slide, we can see our approach to these symmetric keys with multimodal. For our symmetric key approach, which we call multimodal KES, we actually take the PQC algorithms and deploy them using a hybrid approach. So we use ML-KEM, which is the one PQC algorithm that NIST approved, along with a classical encryption using elliptic curve, and a pre-shared key as well. And that pre-shared key is not based on any mathematical assumptions. It's actually just random data that comes from what we call a key distribution hub here. That hybrid approach has a lot of benefits in that it allows us to ensure that the end key that's used has all the benefits of those existing technologies rolled into the resulting key. So if you were looking to compromise any of the end data, you actually need to compromise both the elliptic curve components, the PQC component, and the infrastructure that's providing that pre-shared key. So with that, the multimodal approach actually has two components to the infrastructure. The first is that key distribution hub that I mentioned, and that helps manage the various endpoints and securely provides them pre-shared key information so that it can be used to establish communication with the subsequent endpoint. By establishing a central server for this, we avoid any challenges around scalability where each endpoint would have to know unique material ahead of time about the other endpoints. Instead, they communicate with the key distribution hub and leverage the information from there so that they can establish communication with any other endpoint that's registered. The second is the endpoints themselves, which have a key agent that you see in this picture as the multimodal key agent. That's what actually does the heavy lifting of establishing that end-to-end key. And importantly, it's the only device that actually sees the resultant key as well. So that key derivation function, or KDF, takes place at the endpoint. It doesn't take place in the central server. So that ensures that even if something like the core infrastructure is compromised, your end-to-end keys remain resilient and ensure that they don't have, or that they continue to protect the underlying information as well. So with that, let's look at the demo setup that we have for today. This is a traditional IPsec tunnel, one that's run by through the Juniper devices with the SRX platform. There's on either side of the landscape, you have an SRX platform, and you have the private subnet that's got the client or your corporate services that are behind that. And that public subnet is brokered by an IPsec tunnel that's established using traditional methods. To this setup, we then add two components. One is the multimodal, or two components, one on each side. It's our base jump key agent that supports providing the key into that SRX platform, again, using that ETSI 014 interface. So when the keys need to be rotated, instead of establishing them using traditional ECC type methods, they'll actually go and request those from the same multimodal key agent that we previously talked about. And to do that, we also have the multimodal key agents that talk to each other just over any IPsec connection. So it's nothing that's super unique that's needed for that one. So with that, over to Steve to actually kick off the demo.
So we're going to start in the demo by showing how we configure the IPsec VPN. We're then going to integrate the quantum safe key agents into the policy for the IPsec VPNs. And then we're going to create keys with the multimodal key material. And then from there, we'll see that we're able to establish the IPsec tunnel. And as I mentioned, we're going to leverage existing VPN solutions. We're going to leverage the 8784, RFC8784, as well as the ETSI API that we talked about earlier in this presentation. Both of those have been available in Juniper solutions since Junos release 22R4. So they've been out and available in the market now for a number of years and are fully available, as I mentioned, in a number of our platforms and solutions. So from here, let's take a look at the demo. Now let's look at our demo. In our demo, we're going to show how easy it is to integrate the evolutionQ multimodal key management agent with our Juniper security infrastructure. And this can be used with any of our SRX or vSRX devices, whether physical or virtual, wherever they are in your network. So in this particular demo, we're going to show two SRX 4300s, one at each end of an internet link, and we're going to show their command line interfaces or CLI screens. So the green screen representing SRX 4300-1 and the blue screen representing SRX 4300-2. Now let's take a look at the IPsec configuration for the SRXs. So in this case, we'll look at SRX 4300-1. And as we can see, we have a standard SRX 4300 IPsec configuration, which is the same configuration that you might use, a standard configuration that you might use on any SRX in your network. And as we know, when we set up an IPsec VPN tunnel, there's two components to it, or two security associations. The first one is the IKE association, and the second one is the IPsec association. So we're now going to take a look at the one change that we've had to make to this configuration in order to integrate the evolutionQ multimodal agent. And with that, we're going to look at the actual IKE configuration. So if we look at the IKE configuration here, we can see that there's an additional line that's been added to the configuration, which is this ppk-profile QBT-1. And now let's take a look at that in a little bit more detail. So what we're going to see in this particular aspect or this particular profile within the configuration is that we're actually showing the SRX where to go to get the actual evolutionQ multimodal key material. So we're going to point it here to this web address, this HTTPS web address, where it will fetch the key from when the SRX goes to set up the IPsec configuration. So now with that in place, we're actually going to show the IKE security association, which has been now established with the multimodal key material. And we'll go on and show the actual IPsec security association, which also, as we can see now, has been established with the multimodal key material from the two evolutionQ multimodal key agents, which are on both ends of this particular internet link. So that concludes this part of the demo, and I'm not going to hand it over to Matt, who is going to walk us through what happens when the multimodal key agent gets a request for a key, how it processes that request, and then sends the key material back down to the SRXs. So Matt, I'll turn it over to you.
Thanks, Steve. So what we see behind the scenes here is a couple of different calls between the various components. The first comes from the SRX at site 1, where it reaches out to our base jump agent and says it wants to get a new key. That agent will then go out to the multimodal KDH, retrieve the pre-key data that's used to establish a pre-shared key, and then use that to communicate with the other endpoint and establish, using the asymmetric cryptography, the ECC and the ML-KEM components, taking all three of those, or key material from all three of those communications, and wrapping it together in a resultant key. That gets returned to the SRX device as a key with an ID. The SRX platform sends that ID over to site 2, which then asks for the same key from our base jump platform, and we return it. So it's a number of calls that happen fairly quickly, and in action we can see it quickly run through that as well. So in the next slide, and I think in the video that's there, when we run the video, you'll see the yellow window is our KDH. You'll see it gets the request for the key refresh and provides that pre-key data out to site 1, which is the bottom left green one. That then logs an audit event that says it provided the key up to the SRX platform. And then you'll see in the blue one, which is site number 2, where it gets the same request for the key and provides it back up to the Juniper platform as well. And so with that, they both have the same key and are able to implement that to make a quantum safe tunnel. Back to Steve for, I think, a demo of what happens when you need to do a refresh.
Thanks, Matt. So as Matt mentioned, one of the things that happens in IPsec VPNs is the need to refresh or renew the keys on a regular basis. And this can be scheduled to be done on a monthly, weekly, or daily, or even hourly basis as needed, or determined by the level of security needed for the network. So we're going to, on this particular demo, we're going to walk through what that looks like. Now, in order to keep things moving along, we're going to show this using a refresh rate of about 3 minutes. So here, what we're showing in the top screens is the actual CLI screen again, just like we had before. And then we're also going to see the actual data that's going to be transmitted between the two different devices. So again, we see our SRX 4301, our CLI. We're going to show that that is up, that the actual devices are transmitting data. We see the data that's being transmitted. We see our lifetime, so the life of the key renewal. So we're going to show that now deprecating. So right now we have 81 seconds. We're down to 68 seconds. So I like to share this as the part of the demo where it's like watching grass grow. And what we're going to see happen here in a little bit is we're actually going to see, as we get close to the time where we're going to time out, which we're seeing right now, is the SRXs are going to start initiating retrieving new keys. So they're going to reach out to the evolutionQ multimodal key agents, and they're going to start the process of actually requesting new keys. And then once those new keys are requested, they're then going to implement those new keys. So we can see where they're reestablishing the security association, setting up the new VPN, and all of this is happening in the background. And now we can see that they've reestablished that VPN and converted over without any traffic loss. So Matt, I'll hand it back over to you for our summary before we wrap up.
Yeah, so what are the key things that we learned, I guess, in creating this demo? The first is that we can actually leverage an architecture where we have that out-of-band key establishment using the key agent that gives us a lot of flexibility. Those key agents can be migrated over time. You can switch the methods that they use to establish the keys. And it gives the flexibility to support multiple different applications as well from a single device like that. So rather than having to wait for recertification of kind of the core networking devices, we can actually bring in some agility by using that external key agent and letting it rotate or change algorithms or means to establish the keys more quickly. The second piece, is a big takeaway is that this can actually be implemented today. So we talked about things like the ETSI 014 standard. There are also RFCs out there for IPsec and MACsec that allow for these pre-shared keys or external keys to be leveraged within the existing protocol. So we're following a standards-based approach there. The third is that we can actually create this hybrid method that brings a lot of resiliency when implementing PQC. So we're able to get the benefits of what we know and trust in ECC today, as well as that pre-shared key. That allows us to lower the risk as we're actually shifting over from one time-tested and proven technology like ECC over to our PQC algorithms. And the final one is that we actually, by implementation of that key agent, avoid any of the performance concerns that sometimes crop up as organizations look at PQC. So you were able to see in the demo that Steve showed, we can meet key refresh rates and things like that to ensure that we're not getting any downtime or hitting any bottlenecks in rotating keys like that. So it allows us to have a lot of confidence in this type of use case at least, where we can use this architecture and not have to worry about the performance for that. So back to you, Steve, to wrap us up.
Great. Thanks, Matt. And thank you all for joining us for this demo. If you'd like to learn more about our quantum safe VPN solution with crypto agility, you're certainly welcome to visit us at juniper.net or evolutionQ.com. You can also contact either Matt or myself directly via the emails you see on the screen. And we also encourage you to try it. We've had a number of successful POCs over the past few years of our joint solution in various different types of networks, whether working with data center providers, financial institutions, or across various other industries. So we encourage you to reach out, schedule a POC, and start playing around with quantum and quantum safe technologies today.